Hello once again, ladies and gentlemen, and welcome back. We're up to question number 24 on the grade 7 Gauss paper put out by the University of Waterloo in the year 2002. Alright, so this question, just like one that happened a little while ago, has a nice little figure associated to it, so we're probably going to be referring to that. PQRS is a square. That means that length PS and length SR and length SQ and length PQ, these are all going to be the same side length, and that side length is 8. Okay? X is the midpoint of side PQ. So being the midpoint, it splits it equally in half, as we have they have denoted by these little intersecting lines here. So that means that PX and XQ, they're both going to be the same. They're going to be a half of 8, so they're each going to be 4. So X is the midpoint of PQ, and Y and Z are the midpoints of, so we've joined X to S and to R, the other points in our square, and Y and Z are their midpoints respectively, just as we've shown in the picture. Alright, and we've once again shown that the length has been split in half by saying this length and this length are the same. Okay, as it turns out that these lengths are also the same, that's just a symmetry thing. The area of the trapezoid YZRS is, alright, so if we're trying to figure out the area of a trapezoid, we need to stop and think, okay, what information do I have? That's always a good thing to get straight first. So you write out the information that you do have, so we'll probably figure out some numbers, figure out what we have there. And then we have to ask ourselves, okay, is there a way I can use this information to get more information? Or specifically, get the information that I want, which in this case is the area of trapezoid YZRS. Okay? So as we take a look at this, we're going to redraw our picture. We start thinking, okay, how do I figure out the area of trapezoid? Okay? And so we'll figure out a way to get the area of the trapezoid, and we'll see if we can make that work with the information that we have. All right? So let's redraw this picture in our notebook so we can get started doing a little legwork on the problem. All right. So first, we have our square. I'd say that's a pretty good sized square. So that's P, Q, R, and S. X is the midpoint. So as I've already marked, these guys are going to be 4. This length here is 8. This is 8. This is 8. So we connect each of these up with X. And here we have these midpoints, Y and Z. So I don't know these lengths off the top of my head. I can probably figure them out using the Pythagorean theorem, because I have a 4, 8 here, so I can probably split this guy here. Okay. And then we have this trapezoid, and the area of this trapezoid is exactly what we want. Okay. So, have you thought of a way to figure out the area of a trapezoid yet? One always comes to mind, and I'm particularly happy with the fact that we already have the base of the trapezoid. The one that comes to mind is always, if I can figure out the height of the trapezoid, so we'll call him H, that'll be something we're looking for. And actually we'll keep the red here. If we know this length here, A. So if you've ever seen any trapezoids before, I have a height of, or if I have a top of A and then B, and then I have a height of H, then the area is going to be 1/2 A plus B H. Okay. So if you haven't seen the proof for that, that's actually kind of nice. You take this trapezoid and you sort of rotate 180 degrees, staple it onto the end here, and then you have a parallelogram with base A plus B and a height H. So we figure out that area, but we have 2 of the trapezoids in there, so we half it. So if you've never seen that, that's kind of nifty, and you can go look that up. So if I knew the height here and the base here, this A here, then I could do A plus 8 times h and divide that by 2, and suddenly I'd have the area for my trapezoid. Okay. All right, so I would guess, just by looking at the problem, that h is going to be, so we have this height h here. It looks like he's going to be the same as the height of this triangle. So they should probably both be half of this side length 8. So they should both be 4. But we need to make sure of that. We need to double check that. And as for A, well, A, we might find something nice about this triangle. Maybe for some reason it's equilateral or something. But in terms of figuring out A, what could we do? Well, I'll tell you what, if we were to maybe take a purple here, and this is just purely hypothetical, but I think this will be the same as h. And then if we knew the side length xz, and we knew what h was, because I think it should be 4, then we'd be able to figure out half of A and combine it to make all of A. So I think that's a pretty good attack plan. Okay, we know what we want. It's the area of the trapezoid. Okay, and we know what pieces of information we have missing. We want that A and we want that height h. Okay, so we think of ways to get them. We think of ways to maybe try and work out what h is. Maybe we have a guess as to what h is, but we need to actually show that h is what we think it is. I think it's 4. And then using that information, maybe we can figure out A, and once we have A, h, we combine them with 8, and we can use our area formula and get the area of that trapezoid. Okay, so let's get to work and see what does work. And if we have to come back, we have to rethink different ways to get this trapezoid. So be it. Okay, and we'll cross that bridge when we come to it. All right. Okay. So, let's see here. How do I want to start this off? Okay. So first thing, I want to actually figure out what the length of XR is. That's what I'm going to do first. That way I can tell you what XZ, ZR, XY, YZ. I'm just going to fill out the information here. So that is a right-angled triangle. So by the Pythagorean theorem, we know that XR squared, so our hypotenuse, is going to be equal to XQ squared plus QR squared. But these are known values. It's 4 squared plus 8 squared, so that's 16 plus 64. So that's going to be equal to 80. Now you can punch it in on a calculator, or you can realize 80 is 16 times 5. So XR is going to be the square root of 16 times 5. Square roots distribute over the multiplication symbol, so it's going to be 4 root 5. And so that tells us that XZ, ZR, these are values that we know are all equal. It's going to be 1/2 of XR, so that's going to be 2 root 5. Okay. They have an angle, so we have 2 root 5 here, so we could fill that in. We'll fill it in a little bit. I don't want to clutter up this diagram too much. So I have a little extra information here. Okay. Now, I'm going to, I want to get to this height here. So I actually have a little bit of a triangle here. So What's something we haven't used? We haven't used an A here. So we're going to drop this point A right below Z so that we have our height H here. Okay? So, now, I'm thinking that ZAR and RQX are similar. And how could I show that? So angle ZRA, well, together with angle XRQ, that makes 90 degrees. But together with XRQ and RXQ, that makes 90 degrees. So we should really have RXQ. So this angle is the same as this angle, and this angle is the same as this angle. Okay. So that tells us that triangle ZAR is similar to triangle RQX. Okay. The reason they're similar is all their angles match up. Okay. So we have 90s where A and Q are, and we have these two dot angles are the same, and these two little check or cross angles are the same. Okay. So what does that tell us? Well, we can start figuring out some lengths because we know the ratio of their hypotenuses. Okay, we know that ZR is 2 root 5, and we know XR is 4 root 5. That's the same as ZA RQ, and that's the same as AR QX. If you write the letters in the right order, then this becomes very easy to match things up. But this one is 2 root 5 over 4 root 5, and that's just 1/2. We actually could have seen that without determining that XR is 4 root 5. Just because we already knew that Z as the midpoint splits this thing in half. So we actually figured out some information that we may not have needed yet. Okay, sometimes that happens. Sometimes we work things out, and it turns out we could have gotten the information by other, perhaps simpler means. It's okay, don't worry about it. If you notice something like that when you're doing a contest, don't let it get you bogged down, especially on a multiple choice question where they don't see your work at all. Okay, we can write absolute gibberish for pages upon pages. As long as we get the right answer on a multiple choice, no one knows. No one's checking your answers. That's for the other papers, the Fermat, the Gauss, and the Pesha. We're doing a Fermat, or sorry, we're not doing a Fermat, we're doing a Gauss. So, grade 8 level, no proofs involved. We just want our solution. Okay? So, we know what RQ is, and we know what QX is, right? And AR is 1/2. QX, we know QX is 4. So that's 1/2 4, so that's 2. And we know RQ, well, that's a side length of the whole square. So that's going to be 4. Okay? Now H was ZA, so wouldn't you know it, we did have a height of 4 all along. Okay? So this height here is 4. Now, remember, in lavender, I guessed that this would also be the height. We can see that that's going to go ahead and be the height as well. It's because we have this line here, xz is going to be parallel to the base SR. So it's going to be parallel, and it's going to cut this thing in half. So we have 4 here and a 4 here. But if you don't believe me or didn't follow that train of logic, that's okay. We can see we have another set of similar triangles here. Okay? Right? These two add up to 90. These two add up to 90, and these two add up to 90. So it turns out that we're going to have another similar triangle. So we could let this be B. We'll let B be the midpoint of YZ. We notice that it's actually going to lie directly below H, or sorry, not HX. So that's a height of triangle XYZ. Okay. So XBZ so we get another similar triangle. So in this case, we have triangle XBZ is similar to triangle RQX. Okay. So once again, we have a half is the ratio of side lengths ZR. Oops, no, we don't need ZR. Which one is it? RX and XZ. That's the same as XB RQ, so that's the first two, and then the last two, BZ QX. Okay. Well, we know some of these lengths, right? Right? Just as when we worked the last similar triangle, we know we got this 4 here, this 8 here, and that means that we're going to get a 4 here for the height, and a 2 here for the base. And since B is the midpoint, that 2 combined with another 2 gives us the length for A, which is 2 plus 2 is 4. So we're not going to write it out as complete as we did last time. So XB is going to be 4, and BZ is going to be 2, a half of 4 and a half of 8 respectively. Okay. So side length A is actually going to be, that's YB plus BZ, which is 2 times BZ since B is the midpoint. 2 times 2, which is 4. Okay. So A is 4, H is 4. Now we have enough information to apply our formula. So we have 4 here, we have a 4 here, and we have a base of 8. So the area of YZRS is 1/2 of A plus H, which is 4 plus 8, times the height, which is 4. That's 1/2, 12, times 4, or 1/2 cancels out with the 4, so that's 12 times 2. Which should give us a final answer of 24. And that is our very first one, so that's A. Okay? So our answer for the trapezoid is going to be A. All right? And that finishes up question 24, so we just have one more question to go. And that's question 25, so join me in the next video as we finish off the 2002 grade 7 Gauss paper. Okay? And thanks for watching. I'll see you guys then.